Good. I'm good. It's the second session of the day with X technology. So we today is a NestJS day. It's official NestJS day of the world, and today we celebrate with two sessions in a row. First one was with Andrew, so we continuing our path to splitting the monoliths into microservices, considering different architecture questions and also the algorithms to decompose a monolith. And today, second session is something else, something different. So, Valentin, welcome to the. I think it's third event for you. Every time it's a pleasure to have you. Yeah, first time we had front end related was a React hooks, if I remember correctly.
React hooks, yes.
Yeah, and last time we started a journey into NestJS, and the first episode was about the basics, I believe. So what's gonna be today about?
Yeah, today we will continue our walk through the NestJS, and we will dive a little bit deeper about what's going on under the hood from the request handling point of view. Yeah, because everybody who worked with Node.js, with Express, they remember, okay, if you want to put some handling, there is a middleware. And creators of NestJS they kind of took a little more steps further and added several abstraction layers for the request handling pipeline. And this is quite exciting, quite interesting, but requires a little bit of review before actual work with that. So today we'll talk about this part.
Awesome. Let's kick it off then. Good luck.
Yeah. Let's start. Let's make it. So what we will cover today, as I already started, so we will talk about request handling pipelines, what happens with actual request, how it goes, what is the journey through the NestJS handling, and so on and so forth. It might look very, very simple, simplistic from the first point of view, but it's pretty good to know the at least sequence of what handling happens after which one. And NestJS provides a number of building bricks for request handling and several layers of abstractions. For instance, we'll going to talk about the pipes, which are used for various scenarios, but a lot of use cases are used for the validation of the request. We'll talk about the interceptors, which is a very interesting concept. I will talk about the guards, exception filters, and a little bit about the actual usage, like a little bit of hands-on experience of how those things can be used. But and yes, and all the samples, everything as usual as in the episode 1, you are able to find in this repository, valentin.kononov/Nestor. It's for now it's quite old, so maybe it's already a time to add more samples there, but it still serves for the purpose of the current NestJS setup. So let's start. Initially, I was thinking to show you just the big picture, which I got from the documentation of the NestJS, but decided to simplify it a little bit. So imagine you are HTTP GET request or POST request, doesn't matter. So what you prefer worse. So you came to the API server, which is written with NestJS. So what happens to you as a request first? The very first thing which happens with request, it is sent for the handling to the so-called middleware. And in a simple way, it is the same middleware, everything like in a Node.js Express handler. So it can be one or several functions which would handle request one by one and does something with that. But NestJS, as I mentioned, took a steps forward. So there is a next part. And the next recipient of the request is so-called guard. And again, you can have several guards for every request, for every controller, or every endpoint function. And here we start to come to some understanding why it was created. So there is a logical separation. and you can easily implement certain really small functions with names like security guard or authentication guard or logging middleware, something like that. And already by a name and by the type of the building blocks, the other developers would be able to easily understand the purpose of this piece of code. So why it is needed, what the purpose which it serves. But let's back again. So after passing the middleware and passing all the guards one by one, if there are several ones, our request actually finally gets to the point where the Express or any other underlying functionality would start to understand the routing. So what route we should select for this request and how to handle it further. And here is the first point where another abstract entity can take part, and it is interceptors. Interceptors are super different from all the other building blocks in this pipeline because they are getting executed twice, before the request started to actually be handled and after this handling is completed. So let's take a look. I think we will have a little better understanding once we take a look to the code snapshot. Imagine we passed all the middleware guards, we understand the routing, and even the first part of interceptors, if there are some, has been executed. The next stage, pipes. Pipes is the most simple concept here. It allows to do a transformation. So, for instance, if you have the date as the incoming argument in the body or in the URL parameter, whatever, as a string, and you would like to convert it to the actual datetime object. So you can just implement a simple pipe to do that and do not clutter the actual code of endpoint handlers implementation with that stuff. So your functions became separated and simple to check, simple to test, simple just to implement. Okay, what's next? The next part is the actual controller or actual code to handle what is needed. So the core part of everything is here. All this was just a preparation and additional code to make sure that the request is correct, validated, all the preparatory stuff are done, all the transformations are done, and here we finally come to actual execution, like get some data entity from the database. And after that, after it was executed, we can highlight that interceptors would be able to take the second piece of execution here. So as I mentioned, the interceptor is something which is executed twice. And this is the usual kind of documentation sample, like what the purpose of interceptor is, the performance logging, because we can log the starting time and end time of the request execution quite easily. And yeah, we'll take a look to the sample. It would be better for understanding. But here is the final step, the exception filters. Because after the controller gets executed, we can expect various errors. And usually NestJS would try to get the error and try to wrap it up with something beautiful. But still, there is a chance that a lot of information which can be sensitive from the error, like the database passes, some inner details would be put to the response. And if you don't want to do that and you want to handle different errors, different exceptions differently, you can add several exception filters, which would take care of that. So, Alex, how it looks like from your perspective?
Yeah, thanks giving the opportunity. Actually, I wanted to ask something. First, to clear my understanding a bit, the difference between guards and interceptors, how I understood it. So the guards can make a business logic decision if the route is allowed to be used or not by a particular user, while interceptor is used more for pass through the traffic, basically, right? It doesn't decide to interrupt connection.
Yes, In simple words, yes. So logically, biological design, guard is something where you can easily stop handling the whole pipeline and return like 403 exception or something like that. Because we will take a look to the actual code sample in a minute. In the guard, you will be able to just return false, and the whole pipeline would be stopped, and the controller would never be hit. But when interceptors started to work, even the actual controller has not started to be executed yet, it is not expected that you will stop this. It is still kind of possible, but it is not expected. Yeah, because even the access to the request and response here is not like direct. So it's something which you will see from the sample. But yes, you're right.
Yeah, thanks. The other one I have, it's regarding the pipes. So again, it was always not quite clear to me. Like, how do we, why do we have to use pipes when we can just write utilities and yeah, transform our data if that's needed?
That's a very good question, but the route to answer to that question lies in the same reasons why Nest looks like that. Why Nest looks like that because of declarative approach. So if you have the decorators to use the declarative programming approach everywhere, it's really convenient to keep using that for the utility implementation. So I'll give you a sample. If you have several endpoints which receive the similar parameter, and which parameter needs to be transformed in a similar way, and if you use just a utility function, you will need to call this utility function every time when the controller execution started. And there is a chance you forget to do that, especially if it's still JavaScript. It's a TypeScript, but it's still a little bit, it might be a little bit unclear. And it's like a human factor. But when you have it in declarative approach, you can apply one pipe to all the controllers, like use global pipes and use this pipe, and it would be applied to everything where it makes sense, and you will never have a chance to forget about some utility function usage.
Clear. So it's kind of, for me at least, the same goal as RxJS or Reactive X. It's also a library that is used highly in NestJS has. And this is basically standardize the data pipelines inside the application to have the same filters, transformations, and etc. Yeah.
Yeah, it is. And also, it is designed to bring the sense of the structure and the sense of platform to that, so that the architecture of every API, even with some varieties, it would look a little similar. You will feel very familiar if you change the project. If you starting to dig into the someone else's NestJS code, it will still look familiar. And using those building blocks will give you understanding what is happening and where. So from this point of view, it's kind of just approach to make it more usable and to spend less time in the very beginning when you just start to work with it.
Yeah, got it. Thanks.
So let's take a look to the actual samples in a presentation. And after that, we will be able to jump into the code and discuss more some particularities and have questions and all that. Okay. But please interrupt me. That would be nice. So the first thing, the middleware, it's absolutely simple way. It's just a class which implements the Nest middleware interface with only one method, only one function called use. It has request and response and the next handler. So it is the basics of the basics. So Node.js middleware would look very similar, but without all the types. You can do basically everything there. And here I do nothing. I just put some logger message to identify what is happening right now from the request handling perspective. But the absolutely necessary thing here is to call next handler. As you remember from the Node.js middlewares, every single middleware receives the handler to the function of the next middleware. And if you do not call that next one, the execution pipeline would stop. So it's quite tricky at the moment. And when you're using this kind of stuff, you should understand that this is a little bit hardcore thing from the NestJS perspective. So it's very easy to not keep going with the request if you just forget to call next or by any other reason. But at the same time, you can use it for any purpose if it is needed. If you have some specific use case which doesn't fit into any of other logical concepts as a pipe or guard or anything else. So any kind of hardcore validation, rerouting, anything where you need request and response, it can be implemented here. So this is it. If you don't want to proceed with the whole pipeline execution, you should not call next, but you should put at least something in response. Otherwise, the client side would just receive that. I actually even don't know what it would receive. Something like request, maybe even canceled or empty response, something like that. This is the middleware. Moving on. The next logical part is guards. And guards are logical concepts. Yeah, with a guard, you can actually stop pretty easily the execution pipeline for example, for a security reason or for a role authentication reason. And usually it is quite common when people implement the admin guard or like special user role guard and assign them to the specific endpoints, which should be only available to admins, for example. And the rest works the same. We'll take a look at the actual one later, but here I just put the dummy sample of the custom guard, which implements the canActivate interface. Again, with only one function, canActivate, which returns any kind of Boolean. It could be just true or false, or promise true or false, or observable true or false. Yeah, and as input argument, it receives execution context, which, if needed, can be used with this weird construction to receive the actual request object or response object or something like that. But not every time it is needed. Sometimes you can just put some additional data into the context data, verify it somehow, and return true or false to understand if this can be executed. Yeah, and the execution context can have a couple of things like, which you can see in the bottom part, like get handler or get class. And if I'm not mistaken, this get handler is the actual endpoint. So if you need some kind of metadata from that endpoint function, you can try to obtain it using this. No, not endpoint. It's the next handler in the pipeline. So if there is a sequence of guards, you still have a light chance to get in touch with the next one, but it is not needed. Just returning true or false here is this absolutely okay thing. Okay, I get a feeling that we should take a look at the real sample right now. So if you don't mind, let's just do it. I have here the sample of a role guard decorator.
Wait a second. You need to reshare a screen, I believe.
Oh, really? Okay.
Yeah, right now we just saw the presentation. Yeah, the execution context is a context of application that you can request, right, in your guard. Is that how I understood it?
Not exactly. It is a context of the actual request execution. So if there are several ones simultaneously, they will have different. Because you can use it to receive the actual request. So it's not the full application, it's just one current request.
All right. Can you make it slightly bigger, please?
Oh, yeah.
Yeah, now it's awesome. Right, so the context is a context of a request, and there's no other option. It's only request based. I would imagine you can also have like a singletons versus like one per request option there.
Since it is injectable, you can set up as for every injectable settings, you can set up how it will be instantiated. So you can have a single instance of role guard for any kind of request. But this context is just an input variable, which is received by this function. And every time when it is called by execution code, the context would be put. So this code will put the actual instance of the current request context here, and you will be able to get the request data like URL or authentication token, for instance, any headers, anything like that. So like this, we can use the context switch to HTTP GET request. We also, if I'm not mistaken, can use this kind of stuff. Just give me a second. I have quite. Just a sec. Okay. There is possibility to import request from Express. Yes, and you can use generics to actually specify what is what kind of object you expect to receive. If you know that you are using Express under the hood, and you can take a look to all the fields, everything what is inside here. I will remove it right now because it doesn't have the actual user field which we are adding on the fly in this case. But yeah, so in this actual example, this is the actual example from the real life project. I just modified a little bit and I have some debugging code to just make it go through. What I'm trying to do. First of all, I'm trying to understand the actual role which is specified for the execution function. And how I can do it? I'm using the metadata. I'm just trying to use the reflector instance to get the list of roles by the role parameter from context get handler, which is actual function. And if we take a look to the actual calling, it looks like that. So we have, for example, an endpoint which allows to retrieve the list of users. And we want to make this endpoint available only to admins. So we are using the role decorator, which is also a custom thing, but very simple, to say that it is this list is available only to admins. And using this kind of code, we actually get this role from that reflect metadata using this construction. And then if we have a user, right now we have a user in a request because of the different thing, because our authentication happened. But it's a little bit abstract. It doesn't matter right now. What matters is that we can obtain the user any way. And we have the role which we take from the metadata. And now we just can make a simple assumption. Is the user role is the same as role which is specified in the decorator? And if it is the same, we can just return it. That, okay, this user can get access to this action point. And this is super simplified version, because in fact, if we have list of roles and user can have list of roles, we should not have the exact comparison. In fact, we should search through the roles array to understand it. But let's keep it aside a little bit right now. Okay, Alex, do you have questions in this part?
No, it looks not familiar to me, some of those parts, but yeah, I mean, getting a request Data, that's something that happens quite a lot in Express application, and user, of course, is application-based property. So if you don't add this particular type, then of course NestJS or other typed application will not know about it. So yeah, that's kind of clear.
Okay, and I can also slightly take a look to the role decorator, which is absolutely simple. As I mentioned, this is a custom thing, which I used in the, a little more bigger, which I used in the actual controller, like here, for example, yeah. This is a custom decorator, which is, yeah, absolutely simple. The only thing I just set in the metadata for the taking the parameter of the decorator and put it into the metadata by the certain key, and that's it. So that this data would be available later when it's needed. Basically, the pretty similar approach is used in the libraries like class validators, for example, to save all the validation settings, which will be used later when it's needed. Yeah. Okay. Let's get back to the presentation. And okay, I need to reshare once again. That's weird, but anyway. Entire screen. Yeah, okay. I need to share entire screen. That was my mistake. Good. So we've been talking a little bit about guards, and let's take a look what's next. And next is the interceptors. Again, the interceptor is something like a class, which is injectable because Nest need to instantiate create an instance of that class, and it implements the one single interface called Nest Interceptor with one single method, intercept. Pretty simple. It has something slightly similar to the middleware because it has the context and the next, which is the call handler, something which would be executed as a next step. Yeah, and if you are implementing the interceptor, it is absolutely necessary to call the next dot handle, otherwise everything is stops to function. Yeah, so this is very essential part because only when you call next dot handle, the actual execution of the next pipes would happen, and the execution of controller would happen. And this is next dot handle returns an observable, the standard RxJS observable, and you have all the Rx possibilities to implement anything you want after this execution happens. And the simplest version to use the pipe and with any like tap or map operators to implement whatever you need. In this particular example, which is performance interceptor, we are saving the starting time span, so when the request just started to be executed, and when it is completed, so when this pipe happened, we are putting the information about the total time spent for the request into the log, so that we can just do some minor performance improvements, minor performance debugs.
Quick question.
Sure.
Question on NestJS. On RxJS operators, the pipe and tap. What are those?
You don't know.
I don't remember. Well, pipe
Okay.
I can imagine. The tap I haven't. Yeah, I don't know. Mm-hmm.
Yeah, I'll talk about that. So basically, the pipe is the starting function, which allows you to build a pipeline of handlers after this operation is executed, or every time when this observable is called. Yeah, so it's like just a starting function, the pipe used everywhere. And then inside the pipe, you can provide the sequence of handlers. The top handler would be executed every time when observable is triggered, or in this case, when the function is completed. But it is expected that top would not change the result object. So you just do something without change the result object. If you use map instead of tab, you will be able to return something, and the result object will be changed. So by that, you will be able to modify the not to modify. You can modify response anytime here, but you will be able to modify the return value.
Okay. That's what confused me is that tab says the interceptor completed, but would it be executed just once in this response flow, or it is possible that it will be executed multiple times?
In this case, it will be executed once when the handler is completed. And I'm not sure, I'm not totally sure, so I might be wrong here, but I think there is the unsubscription somewhere inside of the calling functions here. But I'm not totally sure here. Yeah. If it would be just an Angular, for example, and we would assign to some behavioral subject, which might be triggered multiple times, that might lead to the multiple executions and even to some memory leak if you do not handle the unsubscribe properly. But in this case, RxJS is used not just for the actual purpose, but I guess more to be aligned with the whole observability concept with other libraries and stuff. So it's just a simple way to execute something after other thing has been completed. If you are a little bit skeptical about the whole observable and the RxJS concept, you can transform, you can re-implement this by transformer handling to promise and implement something after it is completed, like with await operator or something like that. That might even look more readable, actually. Yeah, that's also possible. You can transform every observable to promise, basically. Okay, just to recap, the crucial thing here is to call next handler, because this would actually trigger the whole execution. Performance use case, the measurement of performance is very obvious. All the documentation says about that, but you can do something else as well with the interceptors. I don't have the actual production samples here and in my repository, but I can imagine, for example, if you want to apply some kind of body archiving or body decoding code, you can use the interceptor here. For example, you can decode in the beginning of the interception and then encode again after the complete of handling. And that would be quite logical, because the whole code of the code and decode would be in the same place. It would be quite easy, and a controller would not know anything about the actual format, about the actual archivation process or something. It would just work with the JavaScript objects, and that's it. But this part would allow you to transform, to change the input-output somehow in the similar way. But it should be aligned with the other parts of the pipelines, of course. Yeah. Okay, let's move on. And we are moving to the probably the most used concept, which is called pipes. And if you remember, the pipe is the last thing which happens before the actual execution of the controller happens. And it has the biggest popularity just because it is the very, very simple concept. And also because the same concept happened to exist in Angular. So there is a pipes in Angular, which looks the same and do nearly the same. So again, it is a class, it is injectable, should be injectable, and it implements the single interface called pipe transform with a single function transform, which receives the value of any type. So, and this is the actual implicit any. So you can do whatever you want with that, but in the interface, there is the actual any here, and some metadata. Yeah. Probably I should. Yeah, we'll take a look later how it is applied, because there are various ways. But basically, the concept is that you can use it for the controller, or you can use it for the parameter, like everywhere. And the usual scenario is, of course, the actual transformation. So you can implement the pipe which transforms the actual data structure, for example. Yeah. So like if the object which is received from the request body is super simple and has just IDs, but you want to receive some additional mapping string data to that ID, so you can implement it here. Or you can transform the string to the data object if it is like that, or something else. So you can do any kind of transformation here. And you can modify this any to like string is expected or object is expected, whatever. But also because of simplicity, this concept of pipes is also used quite heavily for the data validation. I'll give you the sample. Like if you expect that the body of the incoming request, incoming post request, should always has at least ID and name, which are not now. You can implement the special pipe to verify that, and you can just have the couple of if conditions, and if the validation confirms that this incoming object is invalid, you can stop the execution by throwing exception here, by throwing an error. So it is not. I get a light feeling that it is a little bit misdesigned. So when I was reading the first time the description of the pipe transform interface, I didn't expect that I would stop the execution sequence like that. But it is possible. So if you throw exception here by any reason, the execution would be stopped, and the calling side, the client or the browser, would receive the actual 500 exception or something like that, something dependent on the exception filter. And it is so heavily used for in the class validators library and in Nest to validate all the incoming parameters or arguments or body. So this is it. And argument metadata has, there is a pretty good explanation here. So you can access metadata.data, and it would be the string, like the names of items which are passed into the decorator. So it can be body, it can be like if you're validating the parameters, it would be the parameter names, anything like that. Like you can apply. I think it would be easy to show in a sample. And here is the interface, so super simple. And you can use generic if needed. Okay, let's move on. And the last part in that puzzle, last piece of that puzzle, is exception filters. And this is quite obvious concept to my understanding. So you can implement various exception filters, or one big exception filter which work with any kind of exceptions. And there is a different decorator here. So instead of just injectable, you should use add catch, and you can provide the type of exception to be used for this filter. And inside, you can, so this code would be executed when the NestJS environment would catch the specific exception or just any kind of exception. And if I'm not mistaken, that filters would, if you have several filters, first the more specific filters would be triggered, and in the end, the widest filter would be triggered if it is just a catch error, catch any exception. And it received the actual exception, so you can have an access to the message, to some additional stack trace information, anything. And it receives so-called host, which again can be used to switch to HTTP and get the access to the request. Yeah, like get request, get response, and do what is needed. The basic example here is in the standard scenario, standard use case, all the exceptions in Nest are cached, and you can observe them in log or in the result. But in the production, you don't want the exception details into the response, but you might want more details in the logging, like a stack trace. And here I'm actually logging the exception.stack to understand the execution sequence of that exception. And I'm just modifying the response, and I just put the empty thing here, but I can provide anything as a body of response, like just internal server error as a string, or some couple of names like ID of exception is this, and you can contact your administrator for more information, blah, 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 and any status code. Yeah, here it is. Pretty simple. Alex, what do you think? Muted?
Yeah, excuse me. I was looking for the right tab. Yeah, I was looking into the documentation actually for that. Yeah, I think it's clear. So to me is yeah, in some way I enjoy that this all functionality is split it into different classes. Like you have like a concept classes that you semantic classes that you can split your application into, but also as usual that the drawback of it is that a little complicates and maybe overcomplicates your code, I think.
Sometimes yes, and of course you need to maintain it, yeah, in different places. And if the like version of Nest increases, for example, and they by any chance would change the interface or something like that, you need to maintain it as well, which is different from the standard middleware approach where you have the simple interface for anything and you're free to design whatever you want. So, but it is the more like not a holy war question, but the question of what you want to achieve. If you want to achieve something super simple, fast, and absolutely flexible, maybe that's not your approach, because this approach would lead you through the platform, would force you to follow some platform accents, some platform ideas, which is kind of good in case if you just implement another API for the purpose of the getting data, for the purpose of some transformation, and you want to make it repeatable, you want to make it supportable. So in this case, it's quite good. So let's take a look to the test code.
Yeah, and I'm eager to actually see the exceptions, custom exceptions use case.
Let's start from that then. Yeah. So let me just a little bit remember what was happening there. And I want to start not from the actual exception filter, but I want to start from the how it is configured. So if we, yes. If we want to configure the exception filters, we can apply it as everything in NestJS. We can apply it in two ways. Usually, you want to have the exception filters for everything. So that's why you need to apply it in main.ts file where you configure the everything related to the whole application. And you can use the function use global filters, and you can provide there an instance of your custom exception filter, and you can even put the actual argument here. And yeah, so in this case, it won't be injectable. It won't get injected every time when something appears. So you will have only one instance of this thing. It will be used as a global filters and work for any case when this exception happens. Yeah. But you can also apply it controller by controller using the decorator use filters. And let me just quickly show it. So I might be wrong, but use. Yeah. So you can have use filters. Yeah, and you can provide the same. Maybe you don't even to instantiate. Yeah, you can apply it like this, And in this case, it will be injectable, and you can apply it to the specific endpoint, or you can apply it to the full controller. Yeah. Or if you want to have it working for the whole application, you can apply it in the main yes with use global filter. So various approaches.
I didn't get it. What the filter would do in this case? Like if we apply it to the endpoint or to the controller, it will be available inside our code.
It would. The concept is you can apply something on the different levels. You can apply pipe on the level of actual endpoint function or parameter or the whole controller or the whole application. And for that, you can use either use pipe on the different levels or use global pipes here when you just getting your application initialized. And the same approach works with the filters. And by filter, they mean exception filter here.
Oh, that's
You
the
can
same as cache
yes,
wrapper?
it is the
then?
same. It is
It's
the
the
same.
same.
Yeah, it is the same. It just has a little bit different name. So if you, I don't know if it's visible, but I can just go inside, and yeah, if you see the actual signature of that use global filter function, you can provide array of exception filters. So it's just a question of naming.
All right.
Yeah, and just to repeat, you have at least 4 different levels how we can apply these filters and pipes. On the global level, on the controller level, on the endpoint level, and on the level of the actual parameter inside endpoint, which for exception filters doesn't make sense, but I think still possible. So for exception filters, I believe it's really important if you have it globally, because you won't forget to apply it when you add the new endpoint or something. So that's super cool. And let's take a look inside. So in the constructor, we need to provide the adapter host, which would be instantiated automatically if it is injected, or you can add it by yourself, as I just did in the main.cs. And inside, you have all the access for the exception, like exception message, exception stack. And you can do the different stuff. So for example, in this case, what I'm doing, I'm trying to understand the status and just get it, or if this undefined use the standard internal server error. And in this example, I took it from the production application where we have the special settings for cache control, and to prevent the issues like if I'm calling the endpoint with the cache control like half an hour and some exception happens, I call it next minute, and it's still the same exception because the browser has cached the result. So in case of exception, I need to update the cache control. What I'm doing right here. So I get the instance of response, and I am updating this header just in case of exception, so that the client would be able to repeat the query pretty soon. This is one of the samples of the custom behavior here. And also, I am actually modifying what I would like to put in the response. And I just want the status, the timestamp when it happened, and what was the URL of this endpoint, so that I can easily debug. And when I see that issue in logs, I can easily debug and understand which kind of endpoint it was. And then I can put this response body by adapter.reply to the actual request handling pipeline. And that's it. But also, yeah, I can do any kind of additional logging.
Awesome. I have a small question on this exceptions flow regarding the developer experience. So do I understand correctly that in my controller, when I specify to use a cache exception decorator on my endpoint, that would mean that it will be handled by this definition that you have on the screen right now. And what I need to do from controller code from my endpoint is to throw it when I think it's legal to throw it, right?
Yeah, Exactly. So the whole idea again lies in the logical separation. So you don't when you are working inside a controller, you might not even know that there is a request or response, or that you're working inside the web API. Yeah, you just receive some inputs, you try to get some data or implement some kind of operation, and if the error happens, or if you understand that something is wrong, you just throw the specific error. And by applying these custom exception filters of NestJS, you will be able to catch the specific error, modify what you would like to put in the response, and handle it this way. So you're kind of splitting the layers of this handling, and you allow controller to know less about the execution context.
Awesome. Thanks.
Yeah. Just once again, this add catch decorator can be put to the actual filter, but in order to apply that filter, you need to use another decorator, like use filter with this class name, or use global filters with instance of that. Yeah, and you can have. I can be wrong here. Oh yeah. So you can have several errors here. Like if you have the custom errors, you can have several ones here, for example, or you can have several custom exception filters if they are behaving differently for different exceptions. And depending on what exception was thrown, the particular filter would be selected and executed. Yeah. Okay. That was exception filters. And let's take a look to the pipe. And I have one example for that. So let. Okay, let's take a look at the pipe. I have the actual pipe implementation, which is the same as in the sample, and this is absolutely dummy and not interesting. So let's take a look to the one from the production, which is also kind of dummy, but it has the interesting approaches. So we used that query object pipe in the following scenarios. Just to remind you, the pipe can be applied to nearly everything, and it can be applied to the parameter, like a query parameter. Yeah, and you can imagine the scenario when the query parameter, the part of URL, in fact, yeah, but you want to use it to the transfer some object, like a JSON object, so that you just want to have it easier and just easier to work with it from the client side. Just put some JSON stringify and object as a part of query parameter. But the actual API would receive it as a string. And if you even if you apply the actual type of the parameter in the NestJS controller, it's still a string because during the execution it is just JavaScript. It doesn't have any types. So for this case, we implemented the query object pipe, which will try to transform the string into the actual JSON object. And again, it's pretty simple. It has the transform, which receives the string and checks, okay, if we have value, we'll just return JSON parse. And then if we don't have value, we'll try to check if there are some default values configured in this pipe. And if so, we'll return it. And some other things like what are default value for if it was array and not array. It doesn't matter. The whole essence is this line. And again, Alex, as you mentioned, you can do the same all the time in a controller, like when you receive it. But it's so useful if you are following the declarative programming approach to just apply this one tiny thing, and it will do the trick. Let's try to search where it's used, actually. And okay, I have too many files. Okay. Good. I have again the same list controller, and the list endpoint of the user controller, and it receives params of type paging. So paging here means the amount of page and the size of the page. So as usual, pretty simple. And if I'm sending this as the string, no matter if I set up the type here, it would receive it as a string, and the whole my execution would fail because I would not be able to use params.number, params.size, because string doesn't have it. So I'm applying the decorator at query, which is a NestJS decorator. I set up that it would try to map the query path with the params name to this variable. And then I'm saying, okay, after you find it, please apply the query object pipe decorator with this type. And this is the starting point when Nest would call our pipe when it received this query parameter. And in the end, we will receive the object of this type instead of just a string. So this is the hands-on production example of how the pipe can be actually used for the good purpose, not for the just login purpose or some demonstration. So it's something we really used a lot. But of course, as I mentioned, the pipes itself I use quite heavily just for the validation. So for instance, I can have the couple of them. Let's imagine that we, instead of just conversion the string to the paging object, we need to verify that the size of the page is not less than 5 or no more than 10, for example. Yes, that would be more useful. And yeah, and I can apply several pipes here. So let's just go inside this pipe.
However, a little concern on this scenario is that it still happens on a client side, right? It's I can imagine UX-wise
No.
that no, because you can control with a stream what data you get from.
Okay,
Sorry,
maybe I don't understand, but we're talking about just the API.
Yeah, I was for some reason thinking about Angular. Sorry, I was looking into the interface, but now it's NestJS clearly.
It's just NestJS, yeah, it's just the server side. Okay, and we actually have a question, so maybe it's a time to name it. So what if we want to throw an error in pipe? For example, when validation, yes. How we can gather all errors from our chain of pipes and then send all of these errors to users. Okay, without using, yeah, I just was about to say you can use class validators. But okay, if you don't want to use the class validators and you have several pipes, probably there is no single exact answer to that. So imagine if you have several validation pipes, once the first of those would throw an exception, then the whole execution would stop and the exception filter would happen if you have it, and then the response with the error would be sent back to the client side. So if, for example, you have the incoming body of 5 fields and you have 5 validators for each of the field, and already the first one has thrown the exception, the other ones won't be validated, according to my understanding. Yeah, so if you want to achieve that, you still need to follow at least class validators approach. So you should use some kind of decorators for the validation metadata, and only one single pipe to validate everything at once. And this is this would be up to you how this validation code would be arranged and executed, but it should be only one thing. Let's just take a look. So if you remember, the validation pipe from class it's the NestJS common, but it has a kind of relation with the class validators. There is only one single pipe. So it uses lots of decorators, it uses lots of metadata inside, but it's only one pipe which runs the validation function, receives the list of errors, and then throws the exception with the whole list of them. I hope I answered your question, Alexander. But let me know. Okay, I wanted to quickly implement one more sample here. Maybe it would be good to demonstrate the pipes work. So I will just a copy of log pipe and name it like max paging size pipe. Okay, and let's name it correctly, like max paging size. Value in this case,
a little
the value
bigger, please. A little.
Oh yeah, of course, of course, yeah. In this case, we already should receive the actual object paging because we will put this pipe into the sequence after the conversion happens. And the only thing we need to validate is if the value dot size is bigger than, for example, say 10, we would like to throw, should be some specific. Okay. But it should be in fact some specific one, but I will just utilize the one exception from Nest, and it requires to have okay, to have new, of course, and the string. Okay, yeah, of course. So we would like to provide a string like paging with size bigger than, okay. Please forgive me, just 10 here. And then it's even. Okay, that would be. So if we have some issues, exception would be thrown. Otherwise, we'll just return value without any conversion because that's not the point here. And we actually even don't need this as an argument. Everything would work quite okay even without it. And that's it. So our next step would be to go back to the user controller and apply another pipe here. And like that. And one thing, if you said here we are creating the pipe by ourselves. So basically, it's if needed, we can even provide a constructor which would receive the max size, which is number with even some default values. And and we can even save it. Yes. Okay. Okay, and we can use it here as well. Of course, with this keyword. Cool. So what we just did, we allowed to pass some specific value here. And the sequence would be following. The NestJS, when the routing already happened, all these pipes, if we have the pipes here, happen, the row guards everything. And then before actually calling this function, NestJS would come through all the settings here and try to map the expected query params to what we have in actual query. And when it received the query with the property name as params, it would go to the URL of the request and try to find out if there is some params part of the query, get this value and put it as input for the transform function of this pipe, so that it get transformed to the actual JSON with the correct type paging. And that in turn would be put as an input parameter for the transform function of this pipe, which would check the max size of the size of this paging. And if everything is okay, the return value would be passed here to the actual function. And if not, the exception would throw, the custom exception filter would catch it, and we will have the nice response. Okay. Alex, do you have any questions while I'm reading questions from audience?
No, I don't. But indeed, there is another question from Alexander. Can we have somehow destructure fields that we get from a query, and we want to apply different transform pipes to the fields?
Okay. If we have several fields from query, you can have it as several arguments here. So my initial idea with that was to support the following. Let me just put a sample of URL so that it is more aligned. So, for example, we have URL like localhost, doesn't matter, API, then we have user as a controller, then we have list as the endpoint name, and then we have query params, which is equal to the following, with size 10 and number 1. So idea was to transform this string into the JSON. If we have params differently, for example, if we have it like in more convenient way, like size 10 and number 1, not number, but like page number, then we will be able to put several add query decorators here. So we'll have one add query decorator with property name size, and it would correspond to the size argument of type number. And then we'll have the same but for the page number here. And we will be able to use both of them here.
Is it the property optional maybe, so we can handle all params at the same in the same functionality? That would be possible.
I'm not sure. Probably yes, but I don't know about that possibility. I know that you can use this add query to try to pick one exact query parameters from the URL and map it and put its value to the size. And I know that if there is no such param, it will be just undefined here. So if you want to verify that it is required param, you can apply something like is required. I might be wrong, so you can implement it by yourself, but you can apply something like is required pipe here, so that again exception is thrown if this exact parameter is missing. Yeah. But to answer the Alexander's question, basically, if you want to destructure the actual parts of the query of the URL, you can use the same approach but several times. And my initial idea was, what if we are passing this as a single object, but corresponding to the one param? So to demonstrate how pipe construction can be used in the more production cases rather than just logging or something like that. And just to, maybe it's we are turning back a little bit to the previous episode, but maybe we didn't pay enough attention there. So apart from add query, you can also have here, how it's called? Yeah, you can also have here add param. Like I would put just ID here, but it doesn't matter. Like ID of type string, which would be taken from the actual URL path, not from the query side, which is after the question mark, but from the path. So for example, let's make it not ID, let's make type, for example. And you can imagine that we have a list of certain type, and the path would look like this. So the routing would expect that the path would have some variable parameter type, and we can get the value of this variable parameter type from the actual path using pretty the same construction, but the decorator name is different. Not query, it is add param. Okay. And again, if I'm not mistaken, we can apply different kind of pipes. Yeah. So there is a suggestion, IntelliSense suggestion, to add the different pipe transform instances here. So if you want to have, you can even use the same query object pipe here, but of course it doesn't usually make sense for the parameters of the URL. But you can verify that it is exist, or it is of a certain type. If you, for example, you have only a couple of available types of those lists here, you can have the pipe transform instance here to verify that this type is only this or that and nothing else. You can implement it like that instead of having two routes, for example. Okay, I hope I answered that question. Alex, do you have any questions?
Yeah, of course, documentation is giving more deep dive into that. But yeah, if, I think for making a correct application, you will need to dive into the docs anyways.
That's always required. But when you have some baseline understanding, it's easy to search for the particular stuff, right? So what have we not covered? So we talked about in the actual code. We talked about the exceptions, about row guards, about interceptors. Middleware, I showed is super simple. I don't want to spend time on that right now. Talked about pipes. Okay, probably I can show you one more thing, which is again from the little bit modified from the production example. It is guard, but we used a similar IP guard in the one very special endpoint, which we used to have the hardcore access to database. So no one else is required have access to that. We wanted it to limit by IP, so that only one certain IP would have access to this on the time. So make it super secure. And it's super simple. So you can get the request instance and get the IP field from the request and just compare if this is what you expect or not. So this is more like a sample what kind of useful information you can get from request object. And the whole structure is the same. So can activate, return true or false. And that's it. Okay. I think that was quite enough for a day, and for the initial idea to talk about the guards, pipes, interceptors, middlewares, and some basic validation techniques. So if anyone has some questions, you still have a couple of minutes, so please push them into chat.
Yeah. Thanks for watching, of course. So, Valentin, what's your future plans to, if you have any to show us in the next stream?
Yeah, I was thinking about episode 3, but I'm a little bit hesitating between dive into the authentication and something else, because the authentication probably is a very useful topic, but it would have much less with Nest and more with actual authentication. So it would be a slightly different thing. So let me keep it open, and I will think about the next topic suggestion. So we will be able to announce it later, and we'll have it somewhere in the middle of April. Okay.
Yeah. Thanks. If you ask me, I vote for authentication patterns indeed, but that's just one opinion. Nice. So, yeah, I think with that we can wrap it up. Anything with the final thoughts? Have you used
Oh, that's a
Fastify with
good question.
NestJS?
I used Fastify with NestJS, and this is super simple. In fact, I can just quickly remind. So you can turn on the Fastify instead of Express with just a simple construction in main.cs like this. And I really use that. It's quite simple. For my case, I didn't notice the super big performance improvements, but of course, it was a quite simple, crude application, so I didn't expect it would have a lot of improvements. And the good thing, what I noticed, I didn't notice any mismatch with existing interfaces, with existing request and response in most of the cases. I cannot remember even the one case where it was a mismatch with Express. So basically everything worked as I created initially. So yeah, it's a cool thing. Good to try using, but just expect if something not working, try to check the request and response interfaces, and maybe from the very beginning use those types from the Fastify namespaces. Yep.
Nice. Yeah. All right then. If nothing to add so far, I will just say one word about our friends from Node Congress. So that's gonna be a conference in a month in Berlin, and there will be lots of cool speakers like Matteo Collina, for example, author of Fastify, and also Ryan Dahl.
Nice, nice.
Yeah, yeah. For the sake of advertising, it's just nice conference, nice content. Feel free to watch. I think one of the days is free. Yeah, with that, I think, we can wrap it up indeed. And I might announce the next session already because I know the topic for that. The Saturday, next Saturday, we are planning to have another session on Remix. And join if you want to see an interesting experiment with using ESBuild to build your own remix, lightweight remix solution if you want to, using ESBuild, using React, and using Fastify.
Nice. Sounds very interesting.
Yeah. And thanks for watching. Please follow if you like the content. Share with your friends, of course. And that's. I guess with that we're gonna celebrate the NestJS International Day and see you around.
See you guys. Thanks for joining.
Thanks, Valentin. It was amazing.